Hello everyone, my name is Adam and I'd like to welcome you to the second video in our series on programming in Java. In the previous video, we wrote our first program as shown here, and I asked the question, why is it that when we print out the number 8 plus 7 in quotation marks, instead of getting 15 as one might assume, we get 87 instead? And we're going to discuss why in today's video. Before we get to that, we have to talk about a big topic in programming first, which is variables. So variable, you might have heard of this in math class, right? It's like x, right? And you could say the variable equals a certain number, like 7, right? And we could do a similar thing in Java, except in this case, you see there's a red underline here because the computer does not know what x is. Now, it will assume it's a variable, but it doesn't know what type of variable. Is it a word? Is it a number? It could be all sorts of things. So we're going to tell it's a number, in this case an integer, right? So in order to tell the computer that x is an integer, we just have to type the keyword int, right? int stands for integer, and we're telling the computer, hey, the x is an integer. And at the end here, we also have another error, and it's just simply because we didn't end our line with a semicolon, right? And that's a big thing in Java right there. Convention is that you and all of your lines of semicolons. That's because, like we discussed in the last video, that tells the computer, hey, this part right here, that's done. Now you can move on to whatever's next, which in this case is printing out whatever's in here. So instead of printing 8 plus 7, we can just print x. And what the computer is going to do is that whenever it gets to line 6, it's going to say, hey, I need to print x. But what is x? And it's going to look up here and say, oh, x is 7, right? So we push run. We say we print 7. Now we can also create another variable, right? We don't just have to use x. We can do another integer, let's say y or something, right? And we can assign this to a 3. And we put a semicolon at the end of our line right there. And now if we want to print out x plus y, you can assume that it's just going to take x and add it to y, and you get 10 right here. And it's interesting to note that what the computer is doing is that it's taking the value on the right, and it's assigning it to the value on the left, right? Now this is pretty intuitive when it's just, you're assigning a constant to some variable. But if you have something like this where x equals y, what this is doing right here is it's not asking if they're equal. It's taking the value of y, which is in this case is 3, and it's assigning it to the value of x. So after this, x now equals 3, and y now also equals 3 from the beginning, right? If we were to swap these around, right here, we see y, say y equals x, and we were to get rid of this first part right here. In this case, instead of both of them equaling 3, we're going to take the value of x right here, and we're going to assign it to the value of y. So we're going to take the value of x, which is 7, and now y equals 7, and x also equals 7 as well. So if we go ahead and try this right here, we just say y equals x. That means that when we get to this point right here, both x and y are 7, and if we push run, we get 14. Now, you may know that, like in math, obviously there's more numbers than just like whole integers, right? You can have decimals like 2.71 or something like that. And if we try to type that in here for x, right, 2.71 or something, and we can get rid of this line right here, we see that it gives us an error. And that's because this is not an integer. And so what we the data type that we use, instead of typing int, we type the word double. And the reason why we use the word double is because the base data type for this is actually called a float, right? Which you can imagine this as like a floating point decimal, like the decimal place can move around. Almost, this is how I like to remember it, instead of just being at the very end. So you can say float like z equals some number like that, right? But the thing is, because of like memory constraints, we often we use the word double, which is just twice the size of a float, basically. So it's a float, but it's larger. It can hold larger numbers, basically. So we use doubles for decimals, right? It starts with a d. So d for double, d for decimal. And if we take this, we can add this to the integer 3 right here. And what's going to happen is that we're going to get a decimal output 5.71 that's just adding them both together. And so it's also interesting to note that you can, if you assign like 2 to the value x, right, because it's a double and you're adding it to an integer, you're output right here is also going to be a double. And how it's going to treat this is that it's going to type 5.0. And this 0.0 is there because it's like it's a decimal place, and it's like, hey, we have to show that it's a decimal place even if there's nothing there. So that's something you do want to be aware of, that if you're adding a double and an integer, or a double with pretty much any other number, you're going to get a answer that's a double. Now, as we looked at in the last video, there are other data types out there just besides numbers. We have strings, right, or words. And so in order to make a new string, we can just say string and then name, right? And we can do the same equal sign, and then we open our quotation marks to start define a new string, and you can say Adam or something like that, right? So now whenever we want to print the word Adam, we can just type name, and pow, it prints out the thing right here. Also, it's worth noting that by convention, naming variables in Java, you always start with a lowercase letter, and then if you want to add more words to it, you don't add spaces, but you capitalize each additional word. Let's say we wanted to have user age or something like that, right? So we could say string user, and then without putting space, but a capital age right here. This is the convention for spelling variables in Java. It's called camel case because it sort of has a hump right here, and each additional word you add has a little hump to it too. But we're just going to keep this at name. Actually, we're going to change this to first name right here. So my first name is Adam, and as you can see, it's right on the line here because now it doesn't know what name is, right? So we're going to change this to first name as well, and if we push run, it does the exact same thing. But now, if we make a new string, last name, right? Very creatively named. And we can put my last name in here, right? Which is Win, and semicolon at the end of the line. And now we want to output the first name plus the last name right there. And variable names are case sensitive too, so you have to make sure you capitalize it correctly. And you push run, it takes the first name and the last name, and it just smashes them together right there with like no regard to any sort of syntax or formation. And this is the sort of the basis as to why, when we saw in the last video, when we added 8 plus the string 7, we smashed it together. But we'll go further into that in just a minute or so. Now, if we want to add a space in there, the easiest solution is just to put a space right there. And it adds a space in there for us. Now, let's say we wanted to print Adam and then attach a number to the end of it. So let's say we wanted to print my name and then my age, right? So, well, we're going to get rid of these integers right here. We're going to do a new integer titled age, and we're going to set that equal to 17 right here. So now we want to display my name down here, and then we want to display the string age, right? Like that, like this. And after that, we want to display the actual age right here. So you see, I'm just declaring a string straight in the print statement, which you can also do right here. And then I'm adding age at the end of it. And so what it's going to do is it's just going to, oh, you see, like it put Adam when, and then it didn't add a space here, and then it put my age at the end of that. But what's actually happening is that it's taking age, and it's like, hey, age is a number, but we want to print it out. So right there, because it's adding it to a string, it's changing age from a number to a string, so that way it can add it together easily and stick at the end of there. So this 17 down here, the computer doesn't know what the value of this is. It just knows that it's 2 characters, a 1 and a 7. And this is why whenever we add integers to strings, that the computer is like, okay, one of these is a string, and it doesn't know what the value is, and so it just smashes it together. So if we have like another integer or something like this, plus integer x equals 2 or something like that, right? And we try to add this to the end of it, right here, what's going to happen is that you're going to get Adam Win age 172. If we wanted to add these two numbers together before we print it, we have to put a set of parentheses around there, because now it's like it's getting here and it's saying, hey, the 2 integers, add them together, and that works. And then after that, it's taking this new integer and it's combining it with this string right here and saying, okay, we have a string right here and we have an integer right here on the right side. Let's convert that to a string, put it together. So if we push run, we get Adam Win age 19. Now in this video, I also want to talk about a few other types of variables. including a very useful variable type called a boolean, named after this guy called George Boole. And let's say we have a boolean answer or something, right? And a boolean is simply a true or false indicator. That's it. It can either be true or it can be false. There's not really much else it can be, right? That's the whole point of a boolean, is if you just want to store a true or false thing. Another thing that you might come across, and I think we'll discuss in a future video, is the char variable type, which is simply a character. So char letter, right, equals A or something like that. I notice for chars, instead of like with strings, we use the quotation marks right here, right? But with chars, we use the single quotes right here. So this denotes that it's a character. And we can use these just like strings when it comes to adding them together with other strings, right? So we can just add letter at the end of this. If we want to just tack it at the end of our thing right here. And there are also some other number types too. So integer is your base integer, your base whole number type, similarly to how like floats are your base decimal type. There's also larger integer sizes, which are called longs, very creatively named. So long y equals 343 or something. And basically, to help conserve memory in the computer, an integer has a maximum number it can be. And for most systems in Java, it's usually around 2 billion. So it can go anywhere from negative 2 billion to just over positive 2 billion. So if you wanted to store a number like 40 billion or something, you would have to use a long. Because a long has significantly more storage capacity than an integer. And likewise, there's also one that has less storage capacity called a short, also very creatively named, which has half as much memory dedicated to it as an integer. And you may be wondering, what's the use of all these different sizes for numbers? And it simply comes down to the efficiency, right? So if the number you're storing is quite small, you can use short instead of integer, and you can save half of your memory from being dedicated to storing numbers, so you can use it somewhere else to make your program run faster, right? Because having our programs run fast is a really big, important thing for user experience. But because of how fast computers run today and the scope of our projects that we're going to be building, we pretty much are good sticking with int for just any type of integer. And ladies and gentlemen, that's all we're going to talk about today. In the next video, we're going to go more into this string variable type right here, and we're going to explore some of its built-in functionality. But until then, I'll see you later. Take care.